Okay. Sorry about being incredibly late. Stream was supposed to start at 8. I just was super tired. Just could not get up. So, very much apologize for that. But I'm here. We're going to knock it out. We're going to take care of it. We're going to do the stuff. Ooh, let's get the music going in the background. So what we are doing today is subnetting part 3, the VLSM, day 15 of the Jeremy's Tech Lab. If you have not already subscribed to Jeremy's Tech Lab, you definitely should. It is crazy good. Okay, it is crazy good. Learning a whole bunch of stuff about networking and all that stuff. My name is Tyler Lemmond, and I'm studying for my CCNA certification as well. So these streams are literally just me to try to hold myself accountable with my study schedule so that way I can take the test. Which is why I didn't give up, and even though I was really tired and didn't want to come here and I'm late, I still came anyway. That's what she said. Anyway, let's do this. Let's check this out, okay? So we're gonna watch the CCNA subnetting part 3. Let's do it.
Subnetting is very important to understand, so I wanted to take it slowly to make sure you don't get confused. In this video, we'll cover the last few important things you should know. So, what exactly will we cover in this video? First of all, I'll go over the answers to last video's quiz questions.
Yeah, we're definitely gonna do that.
Then we'll do a few practice questions using Class A addresses. Then we'll look at another topic in subnetting called VLSM, which stands for Variable-Length Subnet Masks. I'll explain exactly what that is when we get to it. Finally, I'll give you some other resources where you can get more practice subnetting. Okay, here's question 1 from the last video. You have been given the 172.30.0.0 broadcast address.
Oh, whoa, what happened? What? No.
So, what exactly will we cover in this video? First of all, I'll go over the answer. Then, we'll explain exactly what that is when we get to it. Finally, I'll give you some other resources where you can get more practice subnetting. Okay, here's question 1 from the last video. You have been given the 172.30.0.0/16 network. Your company requires 100 subnets with at least 500 hosts per subnet. What prefix length should you use?
Okay, so we should know how to do this. Let's, because of the study session we did yesterday. So let's open up Photoshop here, and we'll walk through it and see if we're correct now that we're armed with our newly found knowledge, because knowledge is power. All right. We don't need that anymore. That's poo-poo. Okay. So we have... Man, I'm so not set up already. Like, I don't have my tablet hooked up or anything for me to write on. Like, what? I thought I was just going to use a mouse. Like, Jesus. Oh, I forgot to set up chat. Not that anyone's really going to chat, but that's okay. I want to hear it. Sometimes people come in and they help me.
Bot Rix has successfully joined the channel.
Okay, fantastic. Okay, so what we have here is 172.30.0.0/16. So it wants to know you're required 100 subnets, at least 500 hosts. So we know that this subnet 2 to the 16th power minus 2. So that's going to be, go over here to the good old calculator. 2 to the power of 16 is going to be 65,536. So 2 to the 16 equals 65,536. So that's how many subnets we have. And yes. And then we have this, which is our usable addresses. If I remember everything correctly. So then we need to figure out the block size of what this 16 is. because we know that we definitely have more than enough. So what we really need is to figure out how to get this number as close to 500 as possible. So let's do 2 to the power of, I don't know, 10. I don't really know how to do powers in my head. Maybe that's something I need to figure out. No, 2 to the power of 5. No, that was way too little. 2 to the power of 8. Ooh, not 86. Okay, we're getting closer. That was 256. I feel like I know that. How do I know that? How do I know that 2 to the power of 8 is 256? I feel like I just recognized the pattern and I'm not sure of it. Let's do 9. So 2 to the power of 9 is going to equal 512. So now I want to make sure that I don't get confused with the number of addresses and the number of subnets. Okay. So I think 9 is the answer because this is going to give us. So here's my problem. Here's what I'm running into. In my brain, I think that this 2 to the power of something equals the number of subnets. Let's see here. The block size is 8. That wouldn't the network. This is from yesterday's study stream. This is the answer. 5 to the or 2 to the power of 5. 5 being the number of borrowed bits. Okay. Yes. 32 is the number of subnets. Yes. So this is getting us the number of subnets. But here's my question. If 2 to the power of something is the number of subnets, but then we subtract 2 from that and that gives us our usable addresses, is that just how it goes? Okay, that's a good question. Okay. Have a few questions. 1. If 2 to the power of x. Why can I not type? What is going on? It's like my hands don't feel right. Is it because I'm on that wire? Yeah, wow, that's crazy. Equals, okay, if 2 to the power of x equals the number of subnets, which is the number of groupings that you can split the addresses into, then how is 2 to the power of x minus 2 equals the number of usable addresses? Okay, did I... x equaling the cider. Okay, we're not going to ask that question yet because we're going to kind of keep going. And then we'll come up with more questions and then we'll hit it all at once because I have a feeling that we're going to hit multiple roadblocks that probably all share the same answer. So anyway, so that's what I'm getting hung up on is that so then what we need to do is divide this number by 256. Yes, our 256 divided by the block size. Okay, which is this. So we have No, we want this one. So that would be 256 divided by 512. Dang it, I hate when I put it in there backwards. Always forget which way it needs to go into the calculator. So that's 2 subnets. But the question is asking, your company requires 100 subnets with at least 500 hosts. So okay, hold on. I'm just going to write this in there. The confusion comes from this question. You have been given the 172.30.0.016 network. Your company requires 100 subnets with at least 500 hosts per subnet. What prefix length should you use? Okay. Okay, still getting this mixed up. So then my thing is, my answer was /9 because 2 to the power of 9 equals 512. And so that means there are 512 subnets with, but that also means that in each subnet there are only 2 addresses? That doesn't make any sense. Because the block size is the amount of addresses in each subnet, and you get that by 256 divided by 512 equals 2. Where am I going wrong? Okay, we're going to let that cook for a second. because I really understood this yesterday. Because this means that there's going to be 13 blocks. Because okay, so so if we go here and we just okay, whatever, that's fine. 2 to the power of 13 is 8,000. Okay, good. So that's the number of this is the number of addresses that are free. And then we divided that by 256, which got 32. So that's our block is 32. So that means that each subnet is going to be 32. That means all of these addresses are divided into 32 in 32 groups. Each of those 32 groups, of course, only 30 of them are functional. Well, I won't say functional, but you know what I mean. They're usable. But according to this would be 2 to the 9, which would be 256, which would give us the block size. So that would give us the amount of subnets that we need, but it's not going to give us the amount of addresses that we need. Okay. Let's see what we're mixing up.
You're mixing up which X goes in which formula, and it's the single most common subnetting mistake, so let's kill it for good. There are 2 different exponent formulas, and they use 2 different X's. Neither X is ever the CIDAR itself.
What do you know?
The clean way to see it.
No, don't. Don't do that. Don't tell me that.
An IPv4 address is a 32-bit ruler,
Yes.
and a subnetting problem cuts it into 3 sections. Bits on the left belong to the
Yes.
parent network, frozen before you arrived. Bits in the middle are the ones you borrow. They're the subnet counter. Bits on the right are host bits. Here's your exact problem: 172.3/16, needing 100 subnets and 500 hosts, solved on that ruler. So the 2 formulas, side by side, subnets equal to the power of new prefix, old prefix.
What? Subnet? This is the first time it's ever told me this. Subnets are equal to 2 to the power of the new prefix minus the old prefix. What? The exponent is the middle section. Bits you borrowed, never the CIDAR itself. Okay. Usable host. Okay. Minus 2. So 32. Usable. What? Okay, hold on.
Prefix. The exponent is the middle section. Bits you borrowed. Never the CIDR itself. Usable hosts equal to 2, 32, new prefix, 2. The exponent is the right section. Bits left over after the prefix takes its share. Also, never itself. Your X was the CDR in both attempts, and that's the whole bug. Watch what actually happened in your work. You computed 2 to the power of 9 equal to 512, and it was the right arithmetic in the wrong slot.
Okay.
Needing greater than or equal to 500 hosts means you need 9 host bits, 2 to the power of 9, 2 equal to 510. But host bits are counted from the right end of the ruler, so the prefix is 32 minus 9, equal to /23. You took the 9.
Where did we get this 32 from? Is that because that's how many bits that are the host bits? Because 16. All right, see here. Okay. All right, let's test this out real quick. $172 30 0 0 16. No, that would be there. That means that there's 16 because 8 plus 8 is 16. So where are they getting 32? 32 bits. 32 bits total. Every prefix is cut. Is a cut point on this ruler. 16 bits frozen. But 16/16 would be a clean cut. 8, because 8 and 8 is 16. So the whole thing, okay, so the whole thing can only be 32. Because 8 times 4 is 32. So is that where we got the 32? Bro, it did not go over this with me yesterday. Like, what the fuck? Okay. So 2 to the power of the new prefix minus the old prefix. But I don't know what the new prefix is. I only know what the old prefix is.
And planted it on the left end as a prefix, which flipped its meaning entirely. Then check the other constraint. Borrowed bits equal to 23 minus 16 equal to 7, and 2 to the power of 7 equal to 128 satisfies. And notice the tidy accounting. So /23 sum to 32. That's your sanity check on any design problem. 2 more things your attempt reveals. A /9 answer is impossible for a second reason. /9 is a shorter prefix than the /16 you were given. Subnetting only ever moves the line to the right. Children have longer prefixes than parents. Moving it left, /16, /9,
That makes
would be
sense.
claiming address space you don't own.
Okay.
And your 256 divided by 512 equal to 2 was mixing the single octet trick into a whole address problem. The 256 shortcut only counts blocks within 1 octet. The general, always works version is 2, host bits. Here 2 to the power of 9 equal to 512 addresses per /23, which, funny enough, is the 512 you computed. In block size terms, /23 puts 7 frozen bits in the third octet. Mask 254, block size 2, and 2 times 256 equal to 512. Same answer, the recipe for every design a subnet plan question. Start from the host requirement on the right. Find the smallest h where 2h2, 2 greater than, or equal to
Still not
hosts
fully
needed.
Understanding.
Prefix equal to 32. H. Then, verify the subnet count with borrowed bits. Hosts fix the prefix. Subnets confirm it. Try one where both constraints bite. 192.168.0.0/16. You need 12 subnets with 4,000 hosts each. What prefix? And does it have any room to spare?
No, because I still don't fully understand. I still not fully understand. How do I know what the new prefix is? I understand where we got the 32 from, because that is the total amount when you add up all the octets. But does that mean the formula is 2 to the what? Go away. 2 to the power of total bits minus new, was it prefix? Also, are hosts and addresses the same? It's still the terminology. Like, we're interchanging all of these words, and it's making me lose the definition of what they are. Like, it said host. Okay, that's fine. I know what a host is. But then it's also using the word host and interchangeable for usable addresses. So, also, are host and addresses the same? Like, number of host does not care if it is a usable address or not. And it is the cider that calculates the number of addresses. So in our example, the number of addresses that we have to work with is 2 to the power of 16, which equals, what is it, like, it's something crazy, 65,053.6. This tells us if this subnet is possible to even answer the question. Yeah, so don't try to gaslight me, buddy. I want you to walk me through it step by step, explaining each step that you did. Okay. And trust me, I know that the video is going to talk to me about it or whatever, but I'd much rather have the video explain something to me and me understand it instead of me struggling to understand it and then it's playing. You know what I'm saying? So up here it's saying that 2 to the 9. Okay, so that was right, but it was in the wrong spot. 32 minus 9 equals 23. You took the 9 and planted it in the left end of the prefix, which flipped the meaning entirely. Like, I didn't know this. Like, we didn't talk about this up here. All right, here we go. What do we got?
New prefix. Old. Let's clear the two concept questions first, because the walkthrough depends on them.
Yes, it does. Thank you.
Hosts versus addresses. Not the same.
Of course not.
Addresses equal to every slot in the subnet. 2 to the power of host bits of them, including the network and broadcast addresses.
Okay, 2 to the power of host bits. That's the decider.
Addresses. Usable hosts equal to addresses. 2. Because those two slots can't be assigned to machines.
Right.
So yes, your formula is right. Addresses equal to 2, 32, new prefix, and then usable hosts equal to that too.
Yeah, okay, no, you missed, fuck.
Says 500 hosts, it means usable ones. So you test 2H2 greater than or equal to 500.
Well, that's what I did. I did 9. 2 to the power of 9 minus 2 is 510.
To 500. Most of the time, the -2 doesn't change the answer, but sometimes it's the whole trap. If a problem asks for 256 hosts, 8 bits gives 256 addresses, but only 256 addresses. Where those questions try to...
Most of the time, the -2 doesn't change the answer, but sometimes it's the whole trap. If a problem asks for 256 hosts, 8 bits given 256 addresses, but only 254 are usable, you'd need 9 bits. What the fuck? If a problem is asking for 256 hosts, 8 bits given, okay? 256 addresses, you would need 9 bits? The -2 is exactly where those questions catch you. I don't understand this. This is what I do not understand. Okay.
Let's clear the two cons. And your 65,530/16 has 16 host bits.
Okay, let's see here. And your 65,563 insight is correct. The parent /16 has 16 host bits. Okay, that's these. That's all these bits right here. Okay, so 2 to the power of 16 addresses is your total budget. So are hosts bits and addresses are addresses? Is that what it is? That's the part everything must fit inside. A genuine flexibility check, and we'll use it in the last step. How do you know the new prefix? You don't. You solve for it. Yes, I fucking know that. God, dude. It's like talking to a teacher who doesn't know the answer. You solve it. You solve for it. It's the unknown in the problem. The givens are the old prefix, which is 16, and the 2 required 100 subnet, 500 host. The new prefix is what falls out. Here is the walkthrough. Step 1, inventory. Old prefix equals 16. So 16 bits are frozen and 16 bits are yours to spend. Okay, that makes sense. Those 16 free bits must be divided between 2 jobs, becoming borrowed bits and continuing subnets, and the rest stay host bits. Okay, now I'm starting to understand. So wherever we go, we're going to borrow, like, so like if I drew it right here, you can't even see my mouse. Okay, if I drew a line right here, then this side would be borrowed and then this side would be free. Okay, now, okay, that makes sense to me. Okay. Borrowed becomes the borrowed bits, continuing subnets, and then the rest stays the host bits, the counting address. Okay. So that's okay. That's a big thing. Those 16 free bits must be divided into 2 jobs. Some being borrowed bits, which are going to be counting subnets, and then the rest of the host bits would be counting addresses. Oh, damn it! So, would it be safe to say that the borrowed bits are hosts? No, are subnets. Wait, fuck. Oh, god damn it. Where was that? Borrowed bits. Okay, so borrowed bits are subnets. And the free bits are the addresses, which then can be later determined what are usable and what are not usable. I always want to add in an extra N or a T to subnets. Okay, step 2, solve the host requirement first. Why first? Because the host bit sits at the fixed right end of the ruler. So they pin down the flexible, not the flexible, they pin down the prefix directly. Need 2 to the power of H minus 2, which needs to be greater than or equal to 500. Well, I did that. 9. 9 works. I.e., 2 to the power of H greater than or equal to 502. Because he's just factoring in, or it is just factoring in the broadcast and the network. Walk the power of 2. 2 to the power of 8 is 256, too small. 2 to the power of 9 is 512, which works. So H equals 9 host bits, given 512 addresses and 10 usable per host. Okay, so that's correct. That's correct. What I need to do is figure out what goes beyond that. What's the next step? Okay, convert host bits to the prefix. So that means that over here we just change this. Well, we can't use that. We can't use 9 because 9 is smaller than 16. Okay, convert host bits into the prefix.
Ivor.
What's up, buddy? We just converted so host bits are counted from the right end of the 32-bit ruler. So that cuts, so the cut sits at 32 minus 9, 23 bits. So basically we needed to only have nine bits. 1, 2, 3, 4, 5, 6, 7, 8. So that means that the line would be here. Way to go, Ty. That means that the line would be there, which makes sense because 8 plus 8 is 16, plus 1 more 8 would be 24, but we need 23, so minus 1. So there's the minus 1 right there. Okay. That makes sense. So the cut sits at 32 minus 9 equals 23. The new prefix is now /23. So here, let's just draw a line right here. And then we're going to kind of do a little bit of tomfoolery over here. So that means /23. So what? That means 2 to the power of 23. That would equal a crap ton of addresses. Here, read it to me again.
Step 3. Convert host bits into the prefix. Host bits are counted from the right end of the 32-bit ruler, so the cut sits at 32 minus 9 equal to 23. new prefix equal to /23. That subtraction is the answer to, how do I know the new prefix? It's just 32 minus the host bits you decided you need.
Okay, so what I'm having trouble reconciling is that the higher the host bit goes, that's basically the new CIDR. The higher that number goes, the fewer addresses you're supposed to have. But in order to get those addresses, that number becomes the power. So 2 to the power of 23. But I also understand that the more addresses you have, the less number of subnets you can have. Okay, hold on.
Step 4. Verify the subnet requirement. Borrowed bits equal to new, old equal to 23 minus 16 equal to 7. Subnets equal to 2 to the power of 7 equal to 128, greater than or equal to 100.
Whoa. Okay, so we have two different formulas. This is what it was trying to tell me earlier. So according to this, dang it. So according to this, we Okay, hold on. I'm gonna type this right here, and then I'll just copy and paste it in a second. Okay. We use the formula in order to figure out where we needed to figure out the new CIDR. No, in order to... Yes. Is going to cut the, I guess, bank of addresses in a usable fashion. To figure out where we needed to cut the... Wow, okay, hold on. I just spelled this. This all wrong. To figure out where we needed to cut the bank of addresses in a usable fashion, which got us a new CIDR. Then what do? Which is 9. Which is also what I got as well. But 9 cannot be the final answer because it's less than 16. Oh my god, dude, I'm so hungry and I'm all out of crackers. That is why we we have to convert the host bits into the prefix. By taking the total of bits 32 and subtracting the 9 we just got. Which equals 23. It's just 32 minus the host bits. So where am I at with this? What does this mean? Convert the host bits to the prefix. The host bits are counted from the right end of the 32-bit ruler, which is over here. That's the host bits. Okay, you can't see it, this part right over here. Okay. So the cut sits 32 minus 9, which is 23. New prefix is 23. So that means our new real cider is 23. Slash 23. Okay. So that subtract is the answer to how do I know the new prefix. It's just 32 minus the host you decided you needed. Step 4, verify the subnet requirements. Borrowed bits equaled new minus old, which that means 23, which is new, minus the old, which is 16, which gives us 7. So we cut this 16 into 7 equal parts. Another problem I am having is that I thought the higher the went the number of addresses decreased, but according to the formula to find addresses is 2 to the power of cider. By this logic, by this logic, 2 to the power of 16 will equal, what was it, 65, 53, 6. But 2 to the power of 23 equals like an ungodly number. Why is Discord up? Two to the power of Yeah, it's a big number. So where did I go wrong? Okay, so we're going to convert the host bits into the prefix. The host bits are counted from the right. Yes, we know this. Okay, so then we're going to verify the subnet requirements, borrow the bits. Okay, so it's... So... So that means the number of subnets is the... Shit, where'd it go? New prefix that I found, 23, and the original prefix, 16. And that means subtracted to make 7 groupings. But if that's the case, then I should have to do 512 divided by 7. 73. Is 73. Meaning that each grouping will have 73 addresses in it. The question asked, well, and then this goes back. The question asked for 500 hosts per subnet. This is where I am also getting confused, because the question is asking for 500 hosts per subnet. It's always good to do good grammar. It helps. I mean, it's not necessary, but it definitely helps. Okay. This is where I'm also getting confused, because the question is asking for 500 hosts per subnet, and we have 73 addresses per subnet. This is why I feel like we are interchangeably using the words host and addresses. Good. Do that. Okay. So then audit with the budget. 16 plus 7 minus 9 equals 32. Okay. The ruler is fully spent, and 128 subnets times 256. Nothing is missing. Nothing invented. then the so slash 23 mask. Block size is 2. And the third octet, subnets matching 172.30. This is where I'm reading. 0.30, 0.1, 0.1, 0.2, 0.0, 0.30, 0.4, and so on. But it's asking for 500 hosts.
You're circling one single confusion now, and it's this. You keep trying to make every number a CDer. The
'Cause they
9 was
are.
never a CDer, not a new CDer that can't be the final answer. It's a host bit count, a completely different kind of number that lives at the other end of the address. That one mix-up is generating all 3 of today's problems, including the last one. Let me show you, then walk the errors. First, yes, your opening summary is safe to say. Borrowed bits count the subnets, the remaining free bits count the addresses, and usable is just addresses minus the 2 reserved slots. That part is locked in.
We're going to listen to that again.
First, yes, your opening summary is safe to say. Borrowed bits count the subnets, the remaining free bits count the addresses, and usable is...
Okay, so borrowed bits count the subnets. Free bits count the addresses. So that means if we go back over here, this counts the subnets and this counts the addresses, which makes sense because the more subnets you have, the less addresses you have. The more addresses you have, the less subnets you have. That's how the balance out. Think of it like a number line. At least that's how I'm thinking of it in my head. It's a number line, and it's just like it's going back and forth like this based off of what we need. Or scale. Scale would be a good one too.
is just addresses minus the 2 reserved slots. That part is locked in. Now the key picture. A prefix and a host bit count measure the same cut from opposite ends of the 32-bit ruler. So 32 minus 9.
Okay, hold on. Let's study this. So prefix slash 23 counted left to right. It's 23 borrowed bits. Okay, and this is inside the 16. Okay, this is where it gets complicated because this is inside the 16. So, and then we have 9 host bits over here. So 23 plus 9 equals 32. Okay, we need to know that. Yes. Well, okay, never mind. Ignore what I said where it said it's inside the 16. It is, but like that's kind of confusing. We just moved it from 16 to 23. So we changed our host bits. So that goes back to that number line thing, right? Okay, keep going.
The 32 minus 9 equal to 23 isn't a conversion to fix a too small seeder. It's just reading the same cut from the other end of the ruler. 9 from the right is 23 from the left.
Okay, so I was counting 9 as the new cider because I don't know why, but that's not it. It was actually 23. It's starting to kind of come together.
Let's clear the 2 concept questions first, because the walkthrough depends on them.
Don't know why it did that.
You're circling one single where the 73 came from. You said 23 minus 16 equal to 7 groupings, then got 73 addresses each. I'm guessing you did 512 divided by 7 approximately. 2 errors stacked there. First, 7 is not the number of groupings. 7 is the number of borrowed bits, and bits are exponents, never counts.
No, that is not what you said. You said that it was 7. You said that there were 7. Okay, like, where is it? Shit. So that'd be 2 to the 7th. $128. That's still not 500. But that doesn't matter because we're needed subnets. Verify the subnets required borrowed bits. The new minus old. 23 is the new. Minus 16 equals 7. So subnets equals 2 to the 7th, which is greater than 100. Damn, we really had to like go on a journey to find that number though.
Three minus 16.
I hate when that happens. Something's going on with my internet. Anyway, we'll have to worry about that later.
Said 23 minus 16 equal to 7 groupings, then got 73 addresses each. I'm guessing you did 512 divided by 7 approximately equal to 73. 2 errors stacked there. First, 7 is not the number of groupings. 7 is the number of borrowed bits, and bits are exponents, never counts.
7 is the
The number
of
of
borrowed
groupings
bits because that's how many borrowed bits there are. I feel like AI is doing a really bad job of explaining this to me, which really lets me down because it used to do a really good job. But it's also one of those things where it only gives an answer as good as my question and as good as how I told it I want it to respond to me.
is 2 to the power
And I
of
didn't do a
7
good job of
equal to 128 subnets. Second, you never divide addresses by anything to get per subnet size. 2 host bits equal to 2 to the power of 9 equal to 512 addresses per subnet already is the per subnet size directly. The division only comes in as a cross-check. 6,500 hosts.
Yeah, it doesn't do well with reading numbers. The division only comes in as cross-check. 65,000 blah. Total divided by 128 subnets equals 512 each. So the scary 500 host, but only 75 addresses. Conditions evaporates. Yeah, you didn't really explain it to me. Each subnet holds 512 addresses. 510 users, we don't care about that. Can comfortably fits inside the 500. And then the sentence right there is the host/address distinction used correctly. 512 addresses, 510 hosts. Okay. So hosts are things that are actually being used. Addresses is everything, all addresses. Hosts is not counting the broadcast and the network. But when you say addresses, you're counting all of them. And okay, another way to say it, hosts are usable addresses. Yeah, but that's also confusing because we use the term host bits a lot. And if hosts are usable addresses, then what are host bits? Okay. Where the 8 million came in.
Where the 8 million came from. Your instinct was right and your formula was wrong. And when those clash, trust the instinct because it's telling you the formula got misremembered. Addresses equal to 2 to the power of 32 prefix, never 2 to the power O prefix. Here's the cruel coincidence that fooled.
No, it is. It is. Don't tell me that, because that's what it is over here. That tells me what the usable addresses are. So here is the cruel coincidence that fooled you. For a /26, the host bits are 32 minus 16, each was 16, and one prefix in all the IPv4 where the prefix is host bits are the same number, because the 16 is the exact same. No. No, I still don't understand when you say, what was that bullshit that it just tried to pull on me? No, here is the coincidence. No, this is it. Because that is not right. To find the addresses of 172.30.0.0/16, you take the sideR. In this case, it is /16, and use it to the power for 2. So it is 2 to the power of 16 equals the number of addresses. And then you subtract 2 to get the number of usable addresses, or I guess we are now calling them hosts. Okay. No, it's not a cruel trick, because 16 is half of 32. No, it's not. That's not what I'm messing with. Looked like 2 to the power of sideR works. It never did. Shit, it's right. God damn it. Two to the power of host bits. It's even in my stupid spreadsheet. God damn it. Okay. I'm upset.
You're circling
Oh
one
my
single
god, I'm even
confusion
more
now.
upset. Stop going all the
And
way
it's
back up
this.
there.
You keep trying to... The whole cheat sheet is 3 lines. Subnets equal to 2 to the power of new old. Addresses equal to 2. 32. New. And hosts equal to that too. And anytime you're unsure which exponent to use, ask the number 1 question. Which section of the ruler am I counting? Middle subnets. Or bright. Or
That was
bright.
weird.
Addresses. Addresses. 15-second poll.
Wow, we went crazy low there for a second. I don't know why that happened. That was weird. Anyway, so damn it, dude, I can't believe I got that confused. Oh my god, that makes me so upset. So make me a step-by-step method in order to answer questions like this that I can use every time. For those of you guys who are just joining, we are trying to answer this question right here. You have been given the 172.30.0.0/16 network. Your company requires 100 subnets and at least 500 hosts per subnet. What prefix length should you use? And as you can tell, I have failed and fumbled considerably. Okay, that's why we had to come back to over here with the good old AI. Okay, basically, I was getting a lot of things mixed up. The host bits with the CIDR, with the CIDR, things like that. So we're gonna. Oh look, we got steps. Okay, let's see what it says.
Right. And the reason it's confusing is that the terminology is genuinely a little sloppy. So let's pin it
That's
precisely.
exactly what I said earlier.
Host bits is the name of a field, not a count of hosts. It's the right-hand section of the address, better read as the host portion. Every possible on-off pattern of those bits is one address in the subnet, which is why 2H gives addresses. Then 2 of those patterns are reserved for jobs. All zeros is the network ID. All ones is the broadcast, and every pattern that's left can name an actual host. So the chain is host bits make addresses, -2 reserved, leaves hosts. Hotel analogy, H-digit room numbers give you 2 rooms, but the lobby and the fire exit aren't bookable. The bits count rooms, hosts counts bookable ones. Here's the every time method, in the order that never backfires. Inventory the givens. Right? 1 inventory, the givens write down 3 numbers, the parent prefix, P, subnets required S, and hosts required per subnet, H. Your budget is 32p free bits, and every one of them must end up as either a borrowed bit or a host bit. To find host bits from H, find the smallest h, where 2H2 greater than or equal to H, the -2 pays for the network, and broadcast slots. Walk the powers of 2 out loud, 256, 512, 1024, until you clear H. Remember, H is a bit count from the right end of the ruler. It is not a prefix and never will be.
Okay.
3 convert to the new prefix equal to 32. H. This isn't fixing anything, it's reading the same cut from the left end instead of the right. 1 cut, 2 measurements, always summing to 32. 4 verify the subnet count borrowed bits equal to new prefix, old prefix. Check 2 borrowed greater than or equal to S. If it passes, your prefix satisfies both requirements. If it fails, the 2 demands don't fit in this parent network. The honest answer is
Okay,
not
that makes
possible,
sense.
not a different formula. Audit the budget 2 checks that catch nearly every slip. P plus borrowed plus H must equal exactly 32, and number of subnets times addresses per subnet must equal the parent's total, 2, 32p. One of your exponents is in the wrong slot. 6 translate to network terms, build the mask from the prefix. Read the block size off the lowest frozen bit in the interesting octet, or 256. Mask value, and list the subnets by counting from the parent's network address and steps of the block size. One habit that makes the method stick. Before writing any exponent, say which ruler section it counts. Middle section, subnets. Right section, addresses. If you can't say which section, stop. That's the moment the 73s and 8 millions sneak in. Closing the loop on the /26 pulse check, H32 minus 26 pulse check, H32 minus 26 equal to 64 addresses, and 3 run in reverse. Now run the full 6 steps on the waiting, 192.16 steps on the one that's been waiting, with 4,000 hosts each. Show me your work step by step. It's built so both requirements squeeze, and only one prefix survives.
Okay.
I'll check each
We're
line.
gonna put a pin in that, and we're gonna see what good old Jeremy has to say. Because, damn, we've been doing this for an hour and 17 minutes on the very first question, 1 minute and 20 seconds in.
This is a simple one. How many bits do we have to borrow to make 100 subnet?
I hate him. He's like, this is a simple one. Let's do it.
You can just count on your fingers. Borrowing 1 bit allows for 2 subnets. Borrowing 2 bits allows 4 subnets. 3 borrowed bits allows for 8 subnets. 4 borrowed bits allows for 16 subnets. 5 borrowed bits allows for 32 subnets. 6 borrowed bits allows for 64 subnets. And 7 borrowed bits allows for 128 subnets. So we need to borrow 7 bits to create enough subnets.
An hour, and he just explained it in 30 seconds. But I will say that I understand his explanation. So if we borrowed 1 more, this would be 17, 18, 19, 20, 21, 22, 23. So what he's doing is that our shit. So what he's doing is, and I'll do it like this so that way we can move it around. Let's make a big fat marker here. Okay. So this is where we are right now. And then he's borrowing 1 bit, then 2 bits, then 3 bits, then 4 bits, then 5 bits, then 6 bits, then 7 bits, which puts us right here. And then that means that since we borrowed those bits, it's 128. And we can even count it too. 16, 17, 18, because these are the bits that we get. 16, 17, 18, 19, 20, 21, 22, 23. 23, which is exactly what we just got a second ago.
Does that leave enough host bits for at least 500 hosts? Let's check. So, borrowing 7 bits means we will use a /23 prefix length, which leaves 9 host bits. Once more, the red bits are the host bits. 9 host bits allows 510 usable addresses, which is enough for the 500 we need. So, that's the answer to question 1. The prefix length will be /23. /23 is written as 255.255.254.0 in...
So the host bits is 2 to the power 9 minus 2. Okay, so that works. And then what we did is we turned all of the borrowed bits into 1s. Because we started at 16 and then we borrowed 7. And then all of this equals 255.
Dotted decimal, by the way. As I mentioned before, make sure you know how to write different prefix lengths in dotted decimal too. Let's go on to question 2. What subnet does host 172.21.111.201/20 belong to?
Okay, we should be able to do this one pretty quick. Okay. So let's not get it confused like we did last time. I'm just going to erase it. It's just easier. Actually, it's not easier, but that's what I'm going to do. Okay. One, 7, 2, 21, 1, 2, 3, /20. So the number of host bits. So what we need to do is count to 20. 8, 16, 17, 18, 19, 20. Yeah. 17, 18, 19, 20. So that means that our line is now here. We're going to lower that a little bit. Okay, our line is now there. So that means that we have 8, 7, 6, 5, 4. We have wait, why did I count down? 8, 9, 10, 11, 12. So we have 12. So we need to go over here and we're going to do 2 to the power of 12 equals our number of addresses, because 12 is our host bits. Dear God, do I understand? Okay, now we take that number and we divide it against 256, which gives us 16. So 16 is our block size. I do think I took a longer way to get here. So our block size is 16. So then we need to look at our interesting octet and divide that by 16. Or, sorry. Six. So the answer is 172.21.6.0.
These questions are easy if you remember the steps I taught you. First, write out the address in binary like this. Then, change all of the host bits to 0. Convert the address back to dotted decimal, and that's the answer.
96.
So, host 172.2.
Dang it, I took such a long way to get there. Oh, what I should have done is then... No, 16 times 6. Yeah, equals... Yeah. So I did it a much longer way, and I forgot a step, which is why his is better. Okay? Because basically what he does is he divides it into the host bits, the borrowed bits, and the frozen bits. We don't really care about the frozen bits, only a little bit based off of like counting wise. And then he zeroes out all the host bits and only leaves the borrowed bits. And then the borrowed bits tell you what the address or what the network address is for that address.
Convert the address back to dotted decimal, and that's the
Yes.
answer. So, host 172.21.111.201/20 belongs to the subnet 172.21.96.0/20. Let's check the answer for question 3 next. What is the broadcast address of the network 192.168.91.78/26 belongs to?
Okay, so now we're doing the same exact thing, except instead of finding the network, we're going to find the broadcast. So we should be able to do the same exact thing. Let's go back over here. And dang it, I hate when I draw it on the wrong thing. Oh, why? Why can't I? Whatever. All right, here we go. 192.168.91.78. Whoops. /26. Shit. I did it all the wrong thing. Whatever. So, fuck. I hate my life. It's because I need to do this not on Photoshop. I'm about to do it again, aren't I? No, I'm not. One 192.168.91.78.26. So 8, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. So that means that we're going to move our little line here to right there. Okay, so that means we have 1, 2, 3, 4, 5, 6. Now we could do it my way, which is way longer, but gives you a little bit more understanding with it. But that's not what we're going to do. What we're going to do is we're going to write out the binary of this. So we know that it has to be. We know that it has to be 64. And then honestly, everything beyond that, it doesn't really matter because it's beyond this right here. So the answer is 60. But we don't know what our block size is. So 64 is the subnet, or is the not the subnet. It is the, what's the word I'm looking for? Network address. That was weird. Okay. So then let's do it the long way so that we can figure out the broadcast. I'm sure that there's a faster way to do the broadcast. I'm sure he's going to show it to us, but we're going to do it this way right now. So 1, 2, 3, 4, 5, 6. So that's 2 to the power of 6. 2 to the power of 6, I believe, is, I don't know. 64. I feel like I knew that. 64. Wow, look what happens when I draw with the mouse. Okay. Now we're going to take that 64 and 256 divided by 64 equals... Did I do that right? Yes. So, man, I always forget that. Yeah, there it is. I put it in wrong. That's why I was like, man, that should not have been a decimal. Okay. It's 4. So our block size is 4. So now what we're going to do is we need to multiply 4 by 64. No. What do we multiply 4 against? So 4 multiplied by 26? No, we multiplied by 6. That gives us 24. So there's going to be 4 blocks of 24. So then we need to figure out what 24 divided by... Or no, we already have it. So it's 24, right? So 24 plus 24... 48. No. Plus 24. 72. No. Plus 24. So it's 96. So it's going to be 95. And the reason it's going to be 95 is because we did the 24s. So 24 plus 20, because each 24 is a subnet. Is a block. So this 0 to 1. So 0 is 1. This is 2. This is 3. This is 4. This is 5. So this fits inside 72. 72 to 96. Sorry, 72 to 95 will be this. So the answer is 95.
So to solve this problem, you follow the same steps as for the previous question, except instead of changing all host bits to 0, you change them to 1. Let's try it out. Write out the address in binary. Then, since we're looking for the broadcast address, not the network address, change all of the host bits to 1. Convert the address back to dotted decimal, and that's the broadcast address for the subnet.
Damn it, I missed it.
So, the answer for question 3 is 192.168.91.127. That's the broadcast address for this network. Let's check the answer for question 4. You divide the network 172.16.0.0/16 into 4 subnets of equal size. Identify the network and broadcast addresses of the second subnet. So the first step to solving this question is to determine the prefix length we must use. To divide the network into 4 subnets of equal size, we have to borrow 2 bits, because 2 to the power of 2 is 4. So when we borrow 2 bits, that makes a /18 prefix length. Change this last bit to 1, and write it in dotted decimal again. 172.16.64.0. This is the network address of the second subnet. Now, to find the broadcast address, simply change all of the host bits to 1. So the broadcast address is 172.16.127.255. So these are the answers to question 4. Finally, question 5. You divide the 172.30.0.0/16 network into subnets of 1,000 hosts each. How many subnets are you able to make? Well, to know how many subnets we are able to make, we have to know how many bits we can borrow. But to know how many bits we can borrow, we need to find how many host bits we need for 1,000 hosts. We will need 10 host bits for 1,000 hosts, because 2 to the power of 10 minus 2 allows for 1,022 hosts. That will leave us with 6 borrowed bits. 6 borrowed bits means we can make 64 subnets. So that's the answer to question 5. Okay, let's get to subnetting class A networks. Look at the size of rest bit field. That is the host portion. There are 24 host bits that we can borrow from.
Yeah, there's still a lot that we could do with that quiz with those 5 questions, but we're just going to keep going on because it's already been an hour and 30 minutes and all we've done is like 3 questions. We haven't even actually done the lesson. So we're going to
Lots of room to make subnets. However, let me remind you that the process of subnetting class A, class B, and class C networks is exactly the same. So let's just do 2 practice questions subnetting class A networks, and then let's move on to VLSM. You have been given the 10.0.0.0/8 network. You must create 2,000 subnets, which will be distributed to various enterprises. What prefix length must you use? How many host addresses or usable addresses will be in each subnet? Let's solve this question just like the other ones. Here is 10.0.0.0/8 in binary and dotted decimal. It's /8, so only the first octet is the network portion, and we have 3 whole octets to borrow from and make subnets. Notice that I wrote the /8 subnet mask down here, 255.0.0.0. Currently, we are borrowing 0 bits, so we can't make any subnets. Instead of going through the whole process of borrowing 1 bit, 2 bits, 3 bits, etc., let's see if you can do it in your head. So, 2 to the power of what equals at least 2,000?
God damn.
Remember, each bit you borrow doubles the number of subnets you can make. 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048. That's 11 borrowed bits. So the answer is 2 to the power of 11.
Damn.
So, borrowing...
Bro just skip counted by doubling. I feel like that's not hard, but like after I get to like 512, I kind of tap out. He went all the way to 2000.
11 bits allows us to create the required 2000 subnets. This means we will use a /19 prefix length. Now, how many hosts will be in each subnet? Well, there are 13 host bits remaining, so that means 8,190 hosts per subnet. So those are the answers. We will use a /19 prefix length, and there will be 8,190 host addresses, aka usable addresses, in each subnet. This is the same process we used for Class B and Class C networks. The numbers are just larger. Let's do one more practice question for a Class A network. PC1 has an IP address of 10.217.182.223/11. Identify the following for a PC1 subnet. 1. Network address. 2.
Okay, we'll do
broadcast
this
address.
later on a review session.
So let's move on to a very important topic, VLSM, which stands for Variable-Length Subnet Masks.
We'll do that on Sunday.
Until now, we have practiced subnetting using FLSM, Fixed-Length Subnet Masks. This means that all of the subnets use the same prefix length. For example, subnetting a Class C network into 4 subnets using /26. However, VLSM, Variable-Length Subnet Masks, is the process of creating subnets of different sizes to make your use of network addresses more efficient. Now, VLSM is more complicated than FLSM, but it's easy if you follow the steps correctly.
Oh, good. Because Lord knows the other stuff was easier.
So that's what I want to teach you now, the step to subnet a network using VLSM. So here's an example small enterprise network. There are 2 LANs in Tokyo and 2 LANs in Toronto. Tokyo LAN A has 110 hosts, and Tokyo LAN B has 8 hosts. Toronto LAN A has 29 hosts, and Toronto LAN B has 45 hosts. Also, there is a point-to-point connection between the 2 routers that we must assign IP addresses for. We are assigned the 192.168.1.0/24 network, and must divide it into 5 subnets to provide IP addresses for all hosts in the enterprise network. If we were to try this with fixed-length subnet masks,
And the
we would
reason
need to
it's 5 is because we're counting the interfaces. 1, 2, 3, 4, 5.
borrow 3 bits to make enough subnets.
Because each interface has to be on the same network.
That would leave 5 host bits left. 5 host bits only allows 30 host addresses, so that's not enough addresses for Tokyo LAN A or Toronto LAN B. However, if we use VLSM, we can assign different subnet sizes to each LAN, which will allow us to make sure each LAN has enough addresses available. So what are the steps to subnet using VLSM? First, assign the largest subnet at the start of the address space. Then, assign the second largest after it. And then repeat the process until all subnets have been assigned, from largest to smallest. If you look at our network here, that means we will assign subnets in this order. First, Tokyo LAN A, which requires 110 hosts. Then, Toronto LAN B. Then, Toronto LAN A, Tokyo LAN B, and finally the point-to-point connection between the 2 routers. So let's do Tokyo LAN A. I want you to pause the video and figure out these 5 values by yourself. Network address, broadcast address, first usable, last usable address, and total number of usable host addresses. We've done lots of practice for this, so I know you can do it by yourself. Pause the video now to find the answers. Okay, let's check out the answers. So I decided to use a /25 prefix length. Why is that? Well, a /25 prefix length leaves 7 host bits, which means a total of 128 addresses, so 126 usable host addresses. We need 110, so /25 is the correct prefix length. That means the network address is 192.168.1.0/25. Convert all of the host bits to 1, and this is the broadcast address, 192.168.1.127. So now we have our answers for Tokyo LAN A. The first usable address is the network address plus 1, and the last usable address is the broadcast address minus 1. And as I just mentioned, 7 host bits allows for 126 usable host addresses, which is 2 to the power of 7 minus 2. So we now have our first subnet, 192.168.1.0/25 for Tokyo LAN A. That /25 subnet uses up half of the address space of the 192.168.1.0/24 network, but that's no problem. Using VLSM, we can assign smaller subnets to these other LANs, and you'll see that there is enough address space left. So next, we should assign Toronto LAN B. So 192.168.1.127 is the broadcast address of Tokyo LAN A. If we add 1 to that, we will get the network address of the next subnet, which will be used for Toronto LAN.
Honestly, this makes way more sense to me. The way I'm visualizing it, and I know that no one else is going to really understand this but me, but in a musical measure, based off of the time signature, you have so much time that is in that measure. And you can divide that up however you see fit based off of what needs to get done. So if you're in a 4/4 measure, you can divide that into 4 groupings of 4, which would be 16th notes, or 8 groupings of 2, which would be 8th notes, or 1 grouping of 4, which would be quarter notes. But you can divide that time up in the same exact way that it's doing this. So in our host network of our /24, we have all of these addresses, right? I think it's 256 addresses, and we used /25 to only use this many. Okay, now I think we went a little bit beyond 120, but that's okay because we still have X amount of addresses left that can be divided up here. Honestly, this to me is making way more sense than the other one was making.
B. Therefore, 192.168.1.128 is the network address of Toronto LAN B. But we're missing one important point. What prefix length should we use for Toronto LAN B? So with this information, I want you to do the same thing for Toronto LAN B. Pause the video and find the prefix.
So if we only need 8 hosts, it should be like /28.
Length we must use, then the broadcast address, first and last
That
usable
might be too
addresses,
small.
and total number of usable host addresses for this subnet. Pause the video now.
I only really care about
Okay,
the
let's
slash
check the
right
answer.
now.
So to accommodate the 45 hosts, we will use a /26 prefix length.
Choose select.
That leaves 6 host bits, which allows for 62 host addresses. That's more than we need, but if we make a smaller subnet with a /27 prefix length, we can only have 30 hosts, which is not enough.
There it is. Yep.
So the complete network address is 192.168.1.128/26. Change all of the host bits to 1, and you get the broadcast address, 192.168.1.191. So here are the answers for Toronto LAN B. For Tokyo LAN A and Toronto LAN B, we've used address space from 192.168.1.0 through 191. These two subnets take up 3/4 of the address space, but that's no problem. There is still room for more smaller subnets. 192.168.1.191 is the broadcast address of Toronto LAN B. So 192.168.1.192.
So this is going to be 27, and then this is going to be 28. This might even be able to be 29.
Is the network address of Toronto LAN A. Once again, though, we have to figure out what prefix length to use for Toronto LAN A. Let's do the same process as with the other LANs. Please pause the video now to find the remaining information.
Because I can find
Okay,
the broadcast
hopefully you found the
usable
answers.
and all that.
Let's check.
That's easy.
Toronto LAN A requires 29 hosts, so we should use a /27 prefix length, which leaves 5 host bits, and therefore 30 host addresses. So 192.168. .1.192/27 is the network address, and 192.168.1.223 is the broadcast address. With this information, we can determine the first and last usable addresses. So here are the answers for Toronto LAN A. Let's check out Tokyo LAN B next. So we've used all the way to 192.168.1.223, which is the broadcast address for Toronto LAN A. There's not a lot of address space left, but with VLSM, we can fit the last 2 subnets into the address space. The next address after Toronto LAN A's broadcast address is Tokyo LAN B's network address. Once again, we need to find the prefix length to use for this subnet. So please pause the video here to find these different addresses for Tokyo LAN B. Okay, let's check the answers.
29.
So because Tokyo LAN B requires 8 hosts,
Dang.
we must use a /28 prefix length. One possible mistake here is using a /29 prefix length. Although /29 allows 8 addresses, remember we must subtract 2 for the network and broadcast addresses.
Yeah.
So really /29 only allows 6 usable addresses. Therefore, we must use /26, which allows 14 host addresses. So the network address for Tokyo LAN B subnet left that we
Okay,
must...
now what is going to get me in trouble, I can already tell, is making sure that I start and stop each address correctly. Another really complicated question would be what is the host network? Man, then we have default gateways and everything. Man, it gets complicated. Jesus Christ.
To sign, and that is the point-to-point connection between these two routers. So we've used address space all the way up to 192.168.1.239. There's not a lot of space left, but that's no problem. Point-to-point connections only require two addresses. 192.168.1.239 is the network address of Tokyo LAN B. Therefore, 192.168.1.240 is the network address of the point-to-point connection. Now, what prefix length should we use? So, as I mentioned in the first subnetting video, it is possible to use a /31 prefix length for a subnet requiring only two hosts. However, for the CCNA test, if you are asked what prefix length to use for a subnet that requires two hosts, I recommend not using a /31. Instead, what other prefix length allows for two hosts? Pause the video here and find your answers. Okay, let's check.
30.
So, a /30 prefix length allows for two hosts. 192.168.1.240 is the network address, and 192.168.1.243 is the broadcast address. So, here are the answers for the point-to-point connections. There are only two usable host addresses, one for the Tokyo router and one for the Toronto router. Okay, so we successfully subnetted this network using VLSM, and there is still a little bit of address space left. Notice that each subnet uses a different prefix length. If we tried to use the same prefix length for each subnet, there wouldn't be enough address space. But with VLSM, we were able to do it and leave some extra address space at the end. So here's a reminder of the steps of VLSM. Start with the largest subnet and assign it at the beginning of the address space. And then proceed to the second largest subnet, etc., and repeat until you have assigned all necessary subnets. VLSM is a great way to use network address space more efficiently. So, over these 3 videos, we have done lots of subnetting practice questions.
Yes.
However, I recommend that you continue practicing subnetting using other resources. Here are 3 websites that provide excellent practice: subnettingquestions.com, subnetting.org, and subnettingpractice.com.
That's one we
Check them out and try out questions from each site. Here's an example question from subnettingquestions.com.
Okay. We're gonna call it right there. This is definitely gonna be our review on Sunday. I need time to let this kind of like sit and like marinate, especially after the whole debacle of this thing. But I do feel really good about this. I'm glad that it came up with this. Actually, can you turn this these steps into a PDF with examples to go with each step? Actually, and make 2 of them, one with just the steps and one with the steps and the one with the steps and examples to go with the steps, to go with each step. Okay. So, yeah. We're gonna call it right there. I hope that you learned something. I hope you had fun watching me crush out on stuff. If you have not already, please subscribe to Jeremy's Tech Lab, and please check out my channel. I'm working on some videos, but I just we're getting into stuff that I don't necessarily know about. Well, I do know about, but I'm learning more about. And the whole point of all my videos are supposed to be very quick and explain things very simplistically. And if I don't feel like I can explain it simplistically, or if I can't get a video somewhere around 5 minutes, I try to keep them around 5 minutes or shorter, or 7 minutes at the max. Sometimes they get a little bit more than that. Oh, these are VODs. But anyway, you can check this stuff out. Subscribe. We will be live again next Wednesday, and then we will have a review session where we're going to review Subnet, VLSM, and VLANs. And honestly, we're probably going to be reviewing that stuff the next 2 or 3 times. because it's that important and it's kind of difficult. So that's what's going on with that. If you want to check out the gaming streams, go to paradiddlepete.com or paradiddlepete.com. Paradiddlepete. We'll be streaming. I don't know what we're going to stream, but we're going to stream something tomorrow on Tuesday. I don't think that there'll be one on Wednesday, though. But anyway, that's what's going on. Give my channel a subscribe, a like, all that stuff. Check out Jeremy. Give him a subscribe, a like, all that good stuff. The links for all of his videos are down below. And I will catch you guys tomorrow. And then on Wednesday. Remember, work with what you got. Build what you need.